This looks broken. Look at this on the screen. We're going to see something that in Rust that you can do. Some languages let you do this. Rust is one of those languages that you can use flow control to do variable bindings, which is unusual. If we look at the screen, we're going to see something that on line 12, what is going on here? Wait a second, let equal an if statement? What's going on? So with Rust and any other language, they provide you flow control capabilities, and the if-else statements are one of them, are one of the more common types of flow control. You need to check data and make decisions based on the values in that data. So like various variables, if they've exceeded a certain range, you need to check to see what their ranges are. For example, we have let in is this number 5 here. We're going to throw it into a case checking scenario where we're going to see if the number is less than 0. So if the number is below 0, we want to print that the number is negative. Or if the number is greater than 0, we want to print that the number is positive. But what if the number is exactly 0? Then in this case, that we want to print out that it's 0. This is a very common scenario that you see in every language. Needs to have this kind of capability. This is one of my favorite capabilities that comes baked into Rust with its ability to do variable assigning. You can bind a variable into data based on the output of an if-else statement. You can do this with other languages, like maybe even Python, for example. However, you can do it in Rust like this, and it does require a few changes, not too many. They are a little interesting. Check it out. You can do this. You can say I want to find a number here, and the number is going to be a big number. So I'm going to create a variable binding and assign it to an if statement. It doesn't make any sense. I really do like this pattern because it's really, really powerful. It's also easy to read and understand what's happening here. So we want to check to see a range of the number and see if it's counted technically as a small number. Technically anywhere, it looks like anywhere between positive 10 and negative 10. So I guess if in this case, if the number is in this range, which it should be because this number has been defined as 5, then we should see that it will print out this small number and then return the number times 10. Otherwise, here's the cool part. You can say else, or you can also have additional else ifs, so you can check other ranges and then add even more flow control. So if it is outside of this range, then we want to print and it is a big number, and so we want to half the number. So we'll do number divided by 2. Here's where the syntax interesting things come in that we need to pay attention to. There's no semicolon here at the end of the statement. That's one of Rust's indications that this is going to be intended to return the value to the upper level scope. Same thing with this line here. We can see there's no semicolon. However, there is a semicolon that comes in here that we do need to add, which you usually don't have onto flow control. Like for example, look at this if statement here. There's no semicolon on this one. It's not there. We're not binding anything. So you don't need to put one. I wonder if you could and it would do anything. Let's see if it will actually break it. Let's see if the compiler is like, no. It lets you do it anyway. It's like, okay. So we see the number is 5. We run through this. We create a variable binding. It is in this range, right? Less than 10, greater than negative 10. So we return that. So it should be 50. In this case, it is. So 5 into 50. 5 is positive and it's a small number. Increase it tenfold. And so we add a semicolon here. So this entire block of code is executed sort of as one part. I really like this. It's really powerful, and this is a really good design pattern in Rust, especially with how it uses memory management. It's all stack based. There's no memory initializations or freeze in Rust, but there's also no garbage collection. So the patterns that they give you are intended for optimal compute capabilities, and this is one of them. This is a good pattern. It's efficient, and it's also pretty easy to read. I really like this. I've used it before in multiple production applications. It works really well. It's also fairly straightforward to understand and read and to maintain. Another approach that you could take to help simplify, although it can increase complexity depending on the density of code that's involved in here, is putting this variable binding into another function altogether. So you could just toss this into a function and then call the function. There is only maybe 1 or 2 additional instruction compute cycles that are needed when you do that, because you have to reference the function call table. So it's just ever so slightly less inefficient, but it doesn't matter if you're only doing it once.